Hello, welcome back. For this video, we will be answering this integral, the integral of negative b plus minus the square root of b squared minus 4ac all over 2a. Now, this integral right here is quite familiar already because this is actually what we've known as the quadratic formula, except that in this case, we're looking for the integral of this expression with respect to a, which means that in this context, a is a variable, and presumably b and c are constants, at least with respect to a. Now, there are many ways of answering this one. And one common, where I saw this problem, one common solution for this one is to integrate this outright by separating the terms, negative b over 2a, and then this square root of b squared minus 4ac all over 2a. That technically works. It's definitely fine. But the problem with that is that you have something here that involves a quadratic term in terms of b squared, actually a radical with respect to a, and then it has a denominator of a, which in a way makes it a bit more complicated than it should be. So for this video, I will be discussing a shorter way of doing this. Actually, I think this is the main intention of the problem. So since we know that this integrand right here is from the quadratic formula, then we can let x be that integrand. So we let x equals negative b plus minus square root of b squared minus 4ac all over 2a. Oops, there should be no dA here. So that ax squared plus bx plus c equals 0. Now this quadratic equation right here, I will not show how we derive that because, as I mentioned, this expression right here is pretty familiar already to us because that's a quadratic formula. So if we know that this x corresponds to this one as the roots of a quadratic equation, then we know that this substitution right here is equivalent to saying that ax squared plus bx plus c is equal to 0. Now this makes things easier because we can isolate the variable a here with in terms of x. So we can isolate the ax squared on this side and then put the bx and c on the right side and then divide both sides by x squared. And eventually we'll get that a equals negative b over x minus c over x squared. And so we can easily get the relationship between dA and dx by differentiating both sides. If we get the derivative of both sides, we get that dA must be equal to b over x squared plus 2c over x cubed dx. Now these are just simple power rules coming from negative b over x. We get b over x squared, and then this one becomes this one. Yes? I hope that's clear. Now this is good because once we know this one, we can easily make the substitution. So we can put this aside for now, and then we go back to the integral that we want. We want the integral of this quantity right here with respect to a. But if we use the substitution x equals this quantity right here, then this whole term becomes just x. And then the differential elements becomes b over x squared plus 2c over x cubed dx. Right? Now remember that we're just integrating with respect to x. And then the x's here are just powers. So we can easily rewrite this, distribute the x to get b over x plus 2c over x cubed. And from here, we can easily evaluate this one as well, assuming you know power rule, of course. So for this one, this is over x, so this one becomes ln of absolute value of x, and then the other one is negative 2c over x, because this is x to the negative 2, right? So you get this is negative 2c over x. And then we just add here the integration constant c, right? And then what's left is just to put back the x in terms of a. Actually, if it's just me, I'd rather have this expression right here in terms of x, and then we just put a caveat at the end that x is equal to this expression right here. But in case you really want to express this in terms of a, then we just substitute back x here. So x is equal to this one here, and then the x on the denominator becomes this one. We can simplify this further a bit by putting the 2a in the numerator. So you get 4ac right here over negative b plus minus square root of b squared minus 4ac. We can technically simplify this further by, let's say, rationalizing this second term or counter-rationalizing this fraction inside the logarithm. But for me, this already works. This form already works. So I'd leave this answer as my final answer. Okay? So the key here is to let this whole expression be x so that ax squared plus bx plus c equals 0. And then we just relate the differential elements. Right? Now this method is good because we can easily integrate as well with respect to b and c. If, for example, for whatever reason, we want to integrate with respect to other variables b and c. So in this next slide, I'll show what if we integrate with respect to b instead of a. So same process, we just relate the derivatives, and then eventually we got something that involves just powers of x. Right? So in this case, this is the final answer. Okay? Again, I just made a typographical error here. There should be no dA right here. Okay, I'm sorry for that. But generally, this is how we solve this kind of problem. Okay? So in general, if you have an expression that you think you can simplify by means of a substitution, then by all means, I suggest that you try using that substitution because that substitution could probably reduce your computation. Okay? So that's it for this video. If you have any comments, violent reactions, just let me know in the comments. Okay? Thank you for watching and see you on the next one. Bye-bye.